Hi, welcome back to my channel, and for today's video, we will be talking for trigonometry series, the trigonometric functions of special angles. Guys, thank you so much for your undying support. For those who are new to my channel, please don't forget to subscribe so that you'll be updated on a lot of videos that I will be uploading soon. So let's start now. So in the concept of trigonometric functions, we do have these special angles in such a way that by these special angles, we don't really need a scientific calculator to get a specific value. Let's say, for example, we want to get the sine of a certain angle, and this angle is a special angle. So in that way, we really don't need for scientific calculator. Instead, we will just be following some theorems from the Euclidean geometry. So recall that in a Euclidean geometry, the sum of the measures of the angle of a triangle is always 180. So I'm gonna take note of that. It's quite different when we talk about hyperbolic geometry. Now, in that case, then we will use that information for us to be able to identify some other special angles. So let's start first discussing number one theorem. We have the 30, 60, 90 degree theorem. So how does it look like? So you have a triangle here. So one of them is 90. So this is a right triangle. And then let's say this one here is 30. And this one here is 60. So what does the 30, 60, 90 degree theorem say? It says here that the side opposite to 30 degrees is half the length of the hypotenuse. And the side opposite to 60 degrees is square root of 3 times the length of the side opposite to 30 degrees. So I'm not gonna prove this one here because this is a result from Euclidean geometry, but this theorem, we're gonna use this in order for us to use this in our topic for trigonometry. So how does it look like? So let's say, for example, you have this triangle here, and then this is your, let's say this is the one that is 60 and this one is 30 degrees. If you have the hypotenuse here measured as, let's say, 4, then the side opposite to 30 degrees, which is this one here, this one is measured as 2 because it says here it's half of the hypotenuse. And then the one that is opposite to 60 degrees is when you multiply that 2 by square root of 3. So you have 2 square root of 3. That's it. So we have theorem number 2. So the theorem number 2 is 45, 45, 90 degree. So if you sum them up, they're actually equal to 180. So meaning to say that this angle here and here are equal. Now remember, this is a right triangle. So let's say this is your A here, this is your B, and this is your C. So if you take a look into the Pythagorean theorem, this is going to be C squared equals A squared plus B squared, right? And remember that in this case, A and B here are equal because the angles opposite to them are actually equal. So without loss of generality, I'm gonna assume that I'm gonna use A here. So I can replace my B here as A. So I have 2A squared. Okay. Now, if you take a look into that, this will imply that your A squared is equal to C squared over 2. And so this is this will imply that your A here is equal to plus or minus square root of C squared over 2. And that's the same as plus or minus C over square root of 2. Now, in this case, since we're actually taking the measure of the length of a triangle, so we're ignoring the negative value. We're only focusing on the positive value. So, what is the implication here? The implication is that if you are given with C, the value of the hypotenuse, you can just divide it by a square root of 2, and that's the same. That's the value of the legs of triangle. So we can now state our theorem here. It says here that the side opposite of 45 degrees is 1 over square root of 2 times the length of the hypotenuse. So let's consider this. So you have a triangle here. Let's say your hypotenuse is, let's say, 4. So meaning to say that if you're looking for the legs, so this is 45 here, this is 45 here. So your A here is actually 4 over square root of 2. Same with your B here, because A and B here are equal. So in order for you to double check on that, if that's really true, then we can use the Pythagorean theorem. So we have A squared plus B squared. We'll see if this is equal to C squared. Now, your C squared here, since your C is 4, so C squared is 16. Now, your A squared, that's 4 over square root of 2 squared, and your B is the same, 4 over square root of 2 squared. So this is still question mark. Now, what is 4 over square root of 2 squared? So that's the same as 16 over 2 plus another 16 over 2. And that's 16. So this is the same as 16. And this is also 16. So therefore, this is true. So we will now be talking about a specific value of our trigonometric functions. Now, always remember that when we talk about a specific value, we always assume that the length of our ray here is actually 1. So that means to say that this is actually 1 here. So, and then it goes either clockwise or counterclockwise. So if it goes counterclockwise, then the value is of the angle is always positive. If it goes clockwise, then the value of the angle is negative. Here are now our special angles. Let's start with 0. Then after that is 30 degrees. And then we have 45 degrees. We have 60 degrees. We have 90 degrees. And then we will go to 180 degrees. Okay, let's start first with 0. So when the angle is 0, that means to say our ray here lies on this. That means there is no angle in between the ray and the corresponding positive x-axis. So meaning to say that since the length here, and then remember that one here, so it goes to say that our cosine of 0 is 1. And then there is no vertical distance from this point here to the x-axis. So therefore, it says here that our sine of 0 is 0. And so, remember that our tangent, as discussed by the previous video, tangent of 0, that's the same as sine of 0 over cosine of 0. Then that's the same as 0 over 1 or 0. And then, we can solve the other 3, but I will just leave it up to you. You can comment down there for your answers if you want. Okay, so let's talk about 30 degrees. So how do we figure out the 30 degrees? Now, without using calculator, we will have this one here. Let's assume this angle here is measured, this ray here is measured 1. And so in order for us to solve the value, we will project a line perpendicular to the x-axis. So this is our 30 degrees here. So since it's perpendicular to the x-axis, so therefore this one here is 90 degrees. So we don't have a choice but to assume this as 60 degrees. Now, remember, in recall with the theorem 1 we have discussed earlier, the side opposite to 30 degrees is half of the hypotenuse. And since the hypotenuse is 1 here, then this is 1/2. And so automatically, this line here is actually square root of 3 over 2 because it is the same as square root of 3 times the side opposite to 30 degrees. Now, so the vertical line here represents the value for the sine and the horizontal line represents the value of the cosine. Meaning to say that our cosine of 30 degrees is square root of 3 over 2, and our sine of 30 degrees is 1 half. So our tangent of 30 degrees, so that's the same as sine, which is 1 half, over square root of 3 over 2. So cancel the 2 here. You'll have 1 over square root of 3, or this is the same as square root of 3 over 3. So that's the value. So see, we are not really using the scientific calculator for us to be able to solve the other special angles. So before we get the value for cosine, sine, and tangent of 45 degrees, we will use 60 degrees first because 30 degrees and 60 degrees are related to each other. In fact, they are co-functions. And remember on our previous videos, when they are co-functions, that means to say that the cosine of 30 is the same as the sine of 60. So meaning to say, this one here is the same as sine of 60 degrees, and this one here is the cosine of 60 degrees. Okay, so meaning to say that our tangent of 60 degrees, that's the same as square root of 3 over 2 all over 1 half. So this is equivalent to square root of 3. Okay, so we will solve now the value for 45 degrees. Okay, so if I'm gonna assume that this one here is 45, we don't have a choice, but this one as well is 45 degrees. Now, according to the theorem number 2 that we have discussed earlier, this is the same as the hypotenuse all over the square root of 2. So that is 1 over square root of 2 here, and this is 1 over square root of 2 here. So meaning to say that our cosine of 45 degrees, that's the same as 1 over square root of 2, or we can say that this is square root of 2 over 2. And that's the same as sine of 45 degrees. And so our tangent of 45 degrees, square root of 2 over 2, all over square root of 2 over 2. So cancel them out, we left with 1. So let's talk about 90 degrees. Now, in this case here, our ray here is now on this level, meaning to say that there is no horizontal distance from the origin, but there is a vertical distance from the origin. So our cosine here of 90 degrees is 0 because there is no distance from the origin to any vertical position, horizontal position, but our sine of 90 degrees here is 1. So question, what is our tangent of 90 degrees without using your calculator? So you may pause this video so that you can think of the answer. Okay, so the answer here is does not exist. Meaning that there is no tangent 90 degrees. Why? Remember that tangent of an angle is equal to the sine of an angle all over the cosine of an angle. So meaning to say you'll have 1 over 0, which is undefined in our real number system. And now, let's talk about 180 degrees. So that means that the ray lies here. So the cosine of 180 degrees and the sine of 180 degrees. In this case here, we don't have the sine value. Why? Because the distance from the origin to any vertical position is 0. There is no vertical distance. But there is horizontal distance. However, it goes to the left, right? So therefore, it becomes negative 1. And so our tangent of 180 degrees is 0 over negative 1. So that's equal to 0. So tangent of 180 degrees is the same as the tangent of 0. Okay, now, we will solve an example here. What are the values of the 6 trigonometric functions when the angle is 120 degrees? Now, first question that we have to evaluate first is, can we be able to use the theorem, the special angle case? Well, if you're gonna double check that on the figure, this is our 90 degrees. This is 0 here. This is 180. So that means to say that this is our 120 degrees. So meaning the angle in between this line here and this line here is 30 degrees. Okay, is it possible to solve for the value of the 6 trigonometric functions? Well, the involvement of 30 degrees in between the 120 and the 90 degrees is actually enough information for us to be able to say yes. In fact, we can just project this angle here, and then this is the 60 degrees. Our value here, remember using the theorem again, this is always 1 here, so the side meaning to say this is 30 degrees. So the side opposite to 30 degrees is half, and then this is square root of 3 over 2. But this half here is the left side of the origin, so this becomes negative. Therefore, our cosine of 120 degrees, this one here is negative 1/2. Our sine here of 120 degrees is this vertical distance here, which is square root of 3 over 2. So our tangent here of 120 degrees, square root of 3 over 2, whole over negative 1/2, and so we get negative square root of 3. So that's all for now. Thank you so much for watching, and I hope you've learned a lot today. If you have comments regarding on this discussion, please write down on the comment section below so that I would know and I can be able to improve the way I teach you over the video. And if you have any clarification, kindly let me know as well on the comment section. Now, before I'll end this video, since we are actually we were able to solve the 120 degree angle, now I would leave you with a question. What are the 6 trigonometric functions of the angle when the angle is, let's say, 150 degrees? Okay? And then 210 degrees, 240 degrees, 270 degrees, 300 degrees, 333 degrees, and the 360 degrees. So I would love to hear any comments, questions, and your answers for this question. So write down below without using calculator. So I hope you'll be honest with that to solve, and then comment down your answer. So thank you so much guys for watching. If you have any questions or clarification, kindly let me know. And again, thank you for all your support. That's all for now, and have a great day. Bye for now.